Hello everybody and welcome back to another episode of Math with Mr. Emond. Today we're going to be continuing on in our unit on absolute value functions and reciprocal functions. We're going to be looking again specifically at absolute value expressions today. And remember from the previous video, there's two cases that we're considering. One where what's in our absolute value expression is positive and one where it's negative. So we're going to take care to remember that for this lesson as well. Let's start off by doing a word problem. So we're in this word problem, we're going to be making an absolute value equation. Let's go through it. A computerized process controls the amount of batter used to produce cookies in a factory. If the computer program sets the ideal mass before baking at 55 grams, but allows a tolerance of 2.5 grams, solve an absolute value equation for the maximum and minimum mass, M, of batter for the cookies of this factory. Okay, well, what we know is that the difference between our mass and our cookies have to be 55 grams. So the difference between the mass of our cookie and 55 grams, it's not allowed to be more than 2.5 grams. Okay, so whatever our mass is, our mass minus that and the absolute value of it cannot exceed 2.5 grams. So that's how we're going to set up our absolute value equation. Remember that there's going to be two cases. There's going to be case one where M is going to be greater than or equal to 0, and case two where M is going to be less than 0. Now there's two ways to solve this, okay? The first way is to create just a regular old number line. And this is kind of I'm going to call it the lazy way, okay? So right in the middle, we have our ideal mass, 55 grams. And let's, go 56 grams, 57. I'm trying to split these up equally. 58 grams, 54, 53 grams, 52 grams, etc. And these arrows mean they're going to go on forever. Now, what do we want? We have a tolerance of 2.5 grams. So from this 55, we can go up 2.5. So that's 1, 2.5. So up to about there. And we can, of course, go down 1, 2.5. So what do we know about our solution? What's the lower end of it? It's actually going to be 52.5 grams. And what's the upper end of it? It's going to be 57.5 grams. Okay, so M can be that or M equals that. And of course, we're talking about cookie mass here. Now, the interesting thing is this is probably easier to do algebraically, right? When we have this expression, and we did this in the previous lesson, when we have this expression, the absolute value of M minus 55 grams, so the mass of the cookie minus 55 grams equals 2.5 grams, meaning the difference between the mass and the ideal mass has to be 2.5 grams. Well, there's two cases, and in the previous video we set it up like this: M minus 55 equals 2.5 and negative M minus 55 equals 2.5. And at this point they're quite easy to solve, aren't they? So you just go M minus 55, drop the parentheses, equals 2.5. You're going to add 55 to both sides to isolate M. And now we have M equals 57.5. Okay, and here we're going to have negative M plus 55 equals 2.5. We're going to subtract 55 from both sides. So we'll have negative M equals negative 52.5. And we're going to multiply both sides by negative 1. And of course, this is going to give us M equals 52.5. Now you can see our numbers are the same, right? We have m equals 57.5 and m equals 52.5. We found the same values. Those are our solutions. All right, let's try these out. So this time we're looking for absolute value expressions that may have an extraneous solution. So let's see how we solve for this. Well, remember there's two cases, right? We're gonna have one case where we have 2x minus 5 equals 5 minus 3x, and another case where we're gonna have the negative of what's in our absolute value expression equals 5 minus 3x. So you solve for both. So 2x minus 5, just drop the parentheses, equals 5 minus 3x. Let's get them both to the same side. So we're gonna add 3x to both sides, and we're going to add 5 to both sides. Now what's this going to do? These terms are gone, and of course these terms are gone. 2x plus 3x is 5x equals 5 plus 5 is 10. Divide both sides by 5 to eliminate what's in front of the x there. And x, of course, is equal to 2. Let's do this one. So we're going to distribute that negative sign. Negative 1 times 2x is negative 2x, and negative 1 times negative 5 is positive 5, equals 5 minus 3x. We're going to do the same process here. When I'm deciding which ones to move, I'm actually looking at the x values, and I'm going to try to move them around so that I'm left with a positive x value. So if I add 3x to both sides, I'm going to end up with a positive x value here. That's how I made that choice. And of course, if my x value is on this side, then I'm going to want to get rid of this one to move it to the other side. So now we have these ones canceling out, and of course these ones canceling out. But if you look closely, this one also cancels out. So we have negative 2x plus 3x is x equals, there's nothing left over here, 0. All right, we need to test our solutions. Always test your solutions. So you have 2 times 2 minus 5 equals 5 minus 3 times 2. I'm just inserting 2 in everywhere that I see an x. Now I have the absolute value of 2 times 2, which is 4 minus 5, equals 5 minus 3 times 2, which is 6. 4 minus 5 is negative 1, so I have the absolute value of negative 1 equals 5 minus 6 is negative 1. Absolute value of negative 1 is 1. Does 1 equal negative 1? No. X does not equal negative 1. Let's try our solution of 0. So we have the absolute value of 2 times 0 minus 5 equals 5 minus 3 times 0. 2 times 0 is 0. 0 minus 5 is negative 5. So we have the absolute value of negative 5 equals 3 times 0 is 0. 5 minus 0 is 5. The absolute value of negative 5 is 5. Does 5 equal 5? Yes. So this one is a solution, and this one was an extraneous root. So we do not include that in our solution. It's just x equals 0. So make sure you're only boxing the solutions that actually work. Let's try this one out. We have two cases again. One where 3x minus 2 is positive, and one where 3x minus 2 is negative, equals 1 minus x. Now, of course, we can just drop the parentheses here. 3x minus 2 equals 1 minus x. I'm going to look at the two sides and see, to make them positive, I'm going to add an x to both sides, which means I'm going to want to get rid of this 2 by adding the 2. Negative x plus x are gone. Negative 2 plus 2 are gone. So I'm left with 3x plus x is 4x, and 1 plus 2 is 3. And of course, divide by 4 to both sides to get rid of this. So x equals 3/4. I'm not going to box this yet because we have to check our answers. Let's distribute the negative signs. Negative 1 times 3x is negative 3x. Negative 1 times negative 2 is positive 2, equals 1 minus x. Now we're going to, again, move things around. I'm trying to make my x's positive. So I'm going to add 3x here, add 3x there, rather than adding x. Because if I just added x here, I would still be ending up with a negative on this side. Because negative 3 plus 1 is still negative 2. So that's why I chose to move it this way. Hopefully you're starting to kind of picture that a little bit more. Now if I'm moving this, then I have to move this one, right? We want them to be evened out. So I'm going to subtract 1 from both sides. That means these are gone and these are gone. Now what do I have? 2 minus 1 is 1, and negative x plus 3x is 2x. And of course, if I want to isolate x, divide by 2, that's going to leave me with x equals 1/2. Now we can check our solutions. All right, so we have the absolute value of 3 times 3/4 minus 2 equals 1 minus 3/4. Now you're going to have to get good at working with fractions. So we know that Mr. Emond made a mistake. There's no print. It's supposed to look like this, right? Okay, now what else do we know? We know that 3 is 3 over 1. And when you multiply fractions, the numerators multiply. So 3 times 3 is 9. And the denominators multiply. So 1 times 4 is 4. So this is 9/4. Okay. And we have minus 2. Now 2 we can also think of as 2 over 1. If I wanted also to have a denominator of 4, then what does this have to be? 8. Because 8 over 4 is also 2. 2 over 1 is 2. So these are equivalent fractions. Now, why would I have done that? Well, because I'm seeing into the future and I'm knowing that I'm going to have to combine these two fractions. So I need a common denominator for that. Now on this side, I'm also going to see into the future. Instead of 1, I'm going to put 4 over 4 minus 3 over 4 because I'm going to combine those fractions later. All right, what's 9/4 minus 8/4? Well, 9 minus 8 is 1. That's 1/4. What's 4/4 minus 3/4? 4 minus 3 is 1. That's 1/4. Not so bad when you know how to work with fractions. What's the absolute value of 1/4? It's 1/4. Does 1/4 equals 1/4? You bet. This is a solution. I can now box it because I checked it. All right, let's try this 1/2 over here. So we're going to want to go up where we can see our absolute value expression. So we have 3 times 1/2 minus 2 equals 1 minus 1/2. Okay. What's 3 times 1/2? Well, again, that's 3 over 2. Minus, now this is 2. I want a denominator of 2 though. So this is going to have to be 4 over 2. 4 over 2 is 2, which is the same as that. So I'm not cheating when I do that. Just doing good math. And of course, I want the same denominator. So 2 over 2 minus 1/2. Okay. What is this? 3 minus 4 is negative 1. So that's negative 1 over 2. And what's 2 minus 1? 1 over 2. What's negative 1/2? The absolute value of negative 1/2? It's 1/2. Is 1/2 equal to 1/2? Yes. All right. So this one did not have an extraneous solution. Both of them were correct. And this is where I'm going to give you a hint for the future videos that we're going to be watching today, just because in the example it says that there is an extraneous solution, especially on tests and quizzes, doesn't mean there actually is one. You still have to check, because I may be trying to trick you. Some of them will, some of them won't. All right. It's going to be your turn. Go ahead and try these out. Make sure you check to see if you have extraneous solutions. When you're done, come back and we'll have the answer waiting for you. For those of you on YouTube, welcome back. We have the solutions for you here. So for this first one, we're going to have to split it up into two cases, right? So we have 3x plus 2 on the first one, and then we have negative times 3x plus 2 on the second one. So for this first one, just drop the parentheses and isolate x, and you end up with x equals negative 3. Plug in your negative 3 into where the x's were and solve, and you will get absolute value of negative 7 equals negative 7, which is not true. That doesn't work. On the second one, you have to distribute that negative sign. Then you're going to isolate x, and when you do, you have x equals negative 1. Of course, plug that in and check your solution, and you will see absolute value of negative 1 equals 1. Yeah, that does work. So our answer here is x equals negative 1. X equals negative 3 does not work. That's an extraneous solution. This one's solved in a similar fashion. Drop the parentheses on the first one, and then on the second one, you have to distribute this negative sign. Solve for x, and you will get x equals 2 on the first side and x equals negative 4/5 on the second. Check your work by plugging in that 2, and you'll find absolute value of 7 equals 7, which of course it does. So this is a solution. Plug negative 4/5 into the other side, make them have common denominators so that you can add or subtract them together, and you end up with negative 21 over 5 equals negative 21 over 5. No, it doesn't. So this is an extraneous solution. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here you will find the next video in this unit. Keep learning, everybody. Take care.